Everyone, please think about it. Deformation of the bridge caused by thermal expansion and contraction due to temperature changes. How is the load from the bridge deck system transmitted to the substructure? Issues such as how to reduce bridge damage under seismic action will all be handled by our bridge bearings. Therefore, in this lesson, let us learn about bridge bearing test detection together. Bridge bearings connect the superstructure and substructure, maintain the integrity of the bridge span structure, can transfer the load from the superstructure to the substructure, ensure the actual stress condition of the bridge span structure matches the design calculation diagram. Therefore, research on bridge bearings is crucial in bridge construction, plays a crucial role. Bridge bearing products can be divided into laminated rubber bearings, pot rubber bearings, and spherical steel bearings. This section focuses on the mechanical performance test methods and evaluation of laminated rubber bearings. The following table 1-to-1 shows the mechanical performance requirements for finished laminated rubber bearings. In the subsequent test process, we must strictly follow the specification requirements for evaluation. Next, we study the test methods for laminated rubber bearings. First, preparations before bearing test. 1. Sample standing and test conditions. The sample should be placed in the test room at the standard temperature of 23 degrees Celsius plus or minus 5 degrees Celsius for 24 hours. And conduct the test at this standard temperature. 2. Test equipment and instruments. 1. Pressure testing machine. The maximum allowed relative error of the pressure testing machine's indication is plus or minus 1%. And ensure the correct loading center. Loading should be smooth and vibration-free. The service load of the press machine can be within 0.4% to 90% of its full load. 2. Measuring instrument. Measuring instruments used in tests shall be periodically calibrated. Free jack and dynamometer. Jacks with dynamometers used in the test. The service load of its jacks and dynamometers can be within 1% to 90% of its full range. Second, test method for mechanical properties of laminated rubber bearings. Test inspection items for mechanical properties of laminated rubber bearings. Taking the compressive modulus of elasticity and shear modulus of elasticity tests as examples. First, compressive modulus of elasticity test. When calculating bearing capacity R in compressive modulus of elasticity test, calculated based on the effective bearing area of the bearing. 1. Sample placement. Place the specimen on the bearing plate of the press machine, as shown in figure 1-4. Align to the center. Deviation should be less than 1% of the sample's short side size or diameter. Gradually load until compressive stress reaches 1 megapascals and stabilizes. 4. Displacement sensors symmetrically installed at the four corners of the bearing plate. Second, preloading. Increase the compressive stress continuously at a rate of 0.03 to 0.04 megapascal/s. 2. Sigma equals 10 megapascals. Holding load for 2 minutes. Then unload continuously and uniformly until the compressive stress reaches 1 megapascals. Hold the load for 5 minutes. Record the dial gauge initial value after preloading 3 times. Third, formal loading. Each loading cycle starts from 1 megapascals. Uniformly load the compressive stress to 4 megapascals at a rate of 0.03 to 0.04 megapascals/s. Holding load for 2 minutes. Then load stepwise at the same rate. with each step at 2 megapascals. Hold each load level for 2 minutes until sigma equals 10 megapascals. Second, reduce the compressive stress from sigma equals 10 megapascals. Unload continuously and uniformly until the compressive stress reaches 1 megapascals. Hold the load for 10 minutes. Third, formal loading is performed 3 times consecutively. Fourth, data acquisition and sorting. Displacement sensors at the 4 corners of the bearing plate. Average of the measured changes. As the cumulative vertical deformation delta C of the specimen under each load level, based on the total thickness of the rubber layer of the sample. Determine under each level of test load. Cumulative compressive strain of the sample. Fifth, calculation of test results. First, compressive modulus of elasticity is calculated as follows. Second, the compressive modulus of elasticity for each specimen is determined through 3 loading processes. The arithmetic mean of the 3 measured results obtained. But the deviation between individual results and the arithmetic mean shall not exceed 3% of the arithmetic mean. Otherwise, the sample should be retested once. Second, shear modulus of elasticity test. First, place the specimen in the aging chamber. After 72 hours, at 70 degrees Celsius plus or minus 2 degrees Celsius, remove. Second, after placing the specimen at the standard temperature of 23 degrees Celsius plus or minus 5 degrees Celsius for 48 hours, then conduct the shear test at standard laboratory temperature. When calculating bearing capacity R in shear modulus of elasticity test, calculated based on the effective bearing area, A of the bearing. When calculating the horizontal tensile force, calculate based on the gross area, A of the bearing plane. 1. Sample placement. Place the specimen on the bearing plate of the press machine, properly configured with intermediate steel tension plate in double shear combination. Align to the center. Deviation should be less than 1% of the sample's short side size or diameter. When the specimen is a rectangular bearing, the bearing shall be sheared along its short side direction, as shown in figure 1-5. Second, apply vertical load. Apply the compressive stress at a rate of 0.03 to 0.04 megapascal/s. Continuously increase to an average compressive stress sigma equals 10 megapascals, and remain unchanged throughout the shear test process. Third, adjust the shear test mechanism of the testing machine. Align the axis of the horizontal cylinder and the load sensor coincide with the symmetrical axis of the intermediate steel tension plate. Fourth, pre-applied horizontal load. At a rate of 0.002–0.003 megapascal/s. Continuously apply horizontal load until shear stress tau equals 1 megapascals. Hold the load for 5 minutes. Then unload continuously and uniformly until the shear stress reaches 0.1 megapascal. Hold the load for 5 minutes. Record the initial value. Preloading 3 times. Fifth, formal loading. First, each loading cycle starts from tau equals 0.1 megapascal. Load stepwise until tau equals 1 megapascals. Increase shear stress by 0.1 megapascal at each loading stage. Holding load for 1 minute. Second, continuously and uniformly apply the shear stress. Tau equals 1 megapascals unloading to shear stress of 0.1 megapascal. Hold the load for 10 minutes. Third, perform formal loading 3 times consecutively. Sixth, test data acquisition and sorting. Displacement sensors under each level of horizontal load. The measured cumulative horizontal shear deformation delta of the sample, according to the total thickness T of the sample's rubber layer. Determine under each level of test load. Cumulative shear strain of the sample. 7. Calculation of test results. First, The shear modulus of elasticity is calculated as follows. Second, the comprehensive shear modulus of elasticity of the specimen composed of each pair of inspected bearings is the arithmetic mean of the three results obtained from three loadings of the specimen pair. But the deviation between each individual result and the arithmetic mean should not exceed 3% of the arithmetic mean. Otherwise, the sample should be retested once. In this lesson, we mainly studied: first, content and method of mechanical properties test inspection for laminated rubber bearings. 2. Preparation work before test detection of laminated rubber bearings. 3. Mechanical performance requirements for laminated rubber bearings. As a member of Brage Engineering Detection Technology, we should maintain a conscientious, responsible, and dedicated work attitude. Rigorous, practical, meticulous work ethic, and the craftsman's spirit of continuous improvement. Realize personal value in the national strategy of building a strong transportation country. After class, please consider the following questions. 1. Classification of bridge bearings. 2. Other performance requirements for laminated rubber bearing tests besides mechanical properties. 3. Instruments for the compressive modulus of elasticity test of laminated rubber bearings. For result evaluation requirements for compressive modulus of elasticity test of laminated rubber bearings. 5. Test methods for mechanical properties of pot rubber bearings and spherical steel bearings.